I hope my screen is visible to you. Let me know in the comments. So talking about our today's plan, firstly, we will be highlighting the market trends, why AI powered communications are growing day by day. Then we will overlook into how Video SDK and Gemini can work together with the live demonstration, and then we will be wrapping up the session with the Q&A. Before we deep dive into this, let me show you a video. Here we can see how Gemini's LLM works in the real time. Let's see how we can empower our AI with the live ears and eyes. Yeah, there is some glitch. Let me see. Yeah, so let's skip this part and let's move to the next slide. So, talking about why AI powered real time communication is a big deal in current time. So, imagine capturing the slice of market which is going to set at the $755 billion in just a decade. Yes, this is the reality of AI powered real time communication, where WebRTC solutions are going to surge at 44.2% CAGR by 2035. This is not just growth, this is the revolutionary change which will be reshaping everything from telehealth to the customer services. Exploring the use cases of this AI powered real time communication, we can have AI translation agent. We can develop a multilingual transcription agent which can transcribe and translate the real time communication using Video SDK. We can have AI interviewer. AI interviewer will be a co-pilot which can listen to the interviewer, which can suggest the follow back questions and summarize the interview on the note. We can have AI game agent, we can have AI meditation coach, we can also have counselor and AI vision agents. Now coming to the system architecture, we will be using Video SDK for this real-time audio video infrastructure. Video SDK comes with bunch of the features like low latency, part control over the participants, screen sharing, HLS and recording like features. Let's see the system architecture which we will be exploring today. So here we have Video SDK as real-time audio video infrastructure. So once our participants joins into the meeting, their audio stream and video streams will be shared to the STT model. STT model will convert our audio frames into the text responses, and text responses will be fed to LLM. Now, as of now, we will be using Gemini, but you can use any of the LLM or you can customize it. Then once LLM responds it with the text, we will be feeding the text to the TTS model again, and the audio track will be inserted back into the Video SDK. So basically what we'll be doing here, Video SDK will capture the audio video frames that will be fed to the Gemini model. Gemini model will process the streams, will reply with the text or the actions which we can render on the call screen. Yeah. Before moving forward to the demonstration part, let me show you how you can use the Video SDK. So you can visit videosdk.live and click on this sign up with free Google, sign up free with the Google part. Then once you log in, you can create the API key, which will be useful to start the meeting. Once you sign up, you will get 10,000 minutes free per month. We also have Harshit here for the live demonstration part. So I would like to hand over this session to Harshit to go with the live demonstration.
Hey everyone, my name is Harshit. Uh, I'll be giving you a live demonstration of our Python example. Let me just share my screen with you. I hope my screen is visible. Okay. Uh, Now we'll get started with the GitHub repo that we have here. This is the Video SDK Gemini Vision AI example. You just have to clone it first. So let's just clone it here. Let me start off with the cloning. Uh, okay. Once the clone is done, you can simply enter this repo, open it in your code editor. Now, the first thing you have to do is simply create two env files, the environment files. You can create one for the agent and one for the client. Once it's done, you just have to follow these following steps. So that would be, let's first copy the token that comes with the video SDK. So here we have the client app that is created in the React White. Just copy and paste this one, and then I'll show you where you can get the token for the video SDK. You just have to open the dashboard of the video SDK. If you have not signed up, I would suggest you to sign that up, and then you can generate a token from here. You can select the number of days that you want to generate the token for, and then you can simply paste it here. Once that's done, you can again, we need the token for the Gemini and the OpenAI. I already have my token here, so I will be adding it here. Once that's done, next thing you need to do is open your terminal, and let's just add the requirements file that comes with the Python. So pip install our requirements.txt. Yeah. Once it's done, you can simply move to the client side and then do an npm install, which will install all the node modules. Once that's done, all you need to do is, to get started, you need to do an npm run dev. So the app has started now, as we can see it here. Let's just add my name here and join the meeting as I'm visible here. Now I will start the agent that we have, the Python agent. So simply add python main.py. Once the Python agent is initiated, you just have to invite the agent here. I'll just keep my mic mute here for a second. So in this demonstration, I'll be sharing my screen to this bot, and this bot will be responding based on what it sees on the screen. So let's open a random Wikipedia page. Let me just share my screen, the Wikipedia page, and let me just unmute it. Hey, what do you see here? What do you see on my screen here? So that's how this bot works. Now I will just shut this app. Okay, now let me just guide you through the code on how it works. So we have here the code for the agent. So let me just make it a bit bigger. So here we have imported a bunch of libraries like Librosa, NumPy, Google Generative AI, which is used for the Gemini. And here we have a bunch of API keys that we will be importing, which is the OpenAI API key and the Gemini API key. And then we have an AI agent class, which we will be utilizing to join the meeting as a participant in the React app. So here we have our init meeting method where we have passed the meeting ID token and the name. And here we are checking if there is a directory to store the screenshot that we'll be taking and sending it as frame to the Gemini AI. And we have started a loop here. We'll be creating a custom audio track because the bot doesn't have its own audio track. So after that, in order to initialize the meeting, we'll be passing the name, meeting ID, authentication token, mic and webcam, these configurations for the bot itself. And we have a bunch of listeners here, audio listener and screen share listeners. And then we have a bunch of listeners for the meeting itself, whether the bot has joined the meeting, bot has left. Same for the goes for the participants in the meeting. And then we have the initialization for the Gemini itself, uh, which will be using the Gemini vision model, that is Gemini 1.5. And once that's done, we have a screen tool that comes with the OpenAI, which will be analyzing the elements that it sees on the screen. These are the bunch of parameters that should be given in order to do that. And then we have our OpenAI intelligence. OpenAI intelligence have these parameters. uh, we have to pass the API key, the base URL, the input audio transcription. We will be using the Whisper model for it, which is the text to speech, and we'll be doing it vice versa as well. uh, Now we have here we will be sending the latest frame of the audio itself, sorry, the latest screen frame. uh, Now we have a handle function call here that we'll be using, which will handle the screen analysis part. Okay, now we have audio listener here. Audio listener will simply process the audio stream, which is we will be simply sending the audio frames from from the mic, and those audio frames will be converted from, let's say we have 48,000 frames of audio, we will be targeting it for 16,000 frames, which will help us lessen the uh, latency time. And then we will be sending those 16,000 frames to the AI intelligence agent itself to process it. Once that's done, we have a add screen share listener where the once the screen share is done, we'll get the frame to process it, and we'll be updating it back. Once the We have another get screen, which will be processing the screen frames that will be given from an array, and then we'll be converting it to byte. Once that's done, we'll be sending it to the vision model itself. Now we have our video SDK methods, which is on meeting join, on meeting left, on participant join, which will simply give us the events for the same, whether the participant has joined or not, or if someone has left the meeting. And then we have intelligence instructions, where we'll be giving what the agent itself has to do within the meeting. And then we have OpenAI instructions here, which I'll be walking you through in video later. On stream enabled method. Once the stream is enabled, we'll get whether it's audio or it's a screen share. And we have same for the on stream disabled, whether the audio is disabled or not, or screen share is disabled or not. Then we have a bunch of event listeners here, which is part on stream enabled and disabled. For it's for the same. We are just calling it here, and we have same participant left as I mentioned above, and then we'll be clearing up the queue of the tasks and everything. Now we have audio stream track here. In the audio stream track, we will be using AV audio frame. Uh, those who don't have idea of AV audio frame, I can share the link with you. Uh, you can check out this documentation for the same. I'll share it in the chat. Okay, let me just go back to the code. Just a second. Yeah. Okay, so the mic was off. I'm sorry for that. Okay, just a second. I have turned it on. My voice is audible for everyone. Okay, I'm sorry. I lost the mic here. Okay. Uh, let's continue from here. Uh, so this is the audio stream track. We have a custom audio stream here where we will be sharing the audio stream within the meeting, and we'll be processing that audio stream here. We have a bunch of parameters here, which is the loop, start, timestamp, frame buffer, frame time, sample rate, and channels, be it mono audio or stereo audio. You can handle that as well. And then we are also having samples, chunk sizes here. Now we have defined a interrupt here, which is basically if let's say somebody talks with while the bot is speaking, if somebody talks, we simply take that as the latest audio, and then we will be processing that. If somebody does not speak anything within that time, then the uh, bot itself will take over from there. So and then we have add bytes here, where the new audio data will be processed and played. And then we have run process audio, which will run a audio coroutine for the same. And then we have a main audio processing loop here, where we'll be simply looping and with a sleep time to get the audio frames. Once that's done, here is the algorithm that we'll be using to send the chunks of frames. We'll be dividing the frames into smaller bytes. As we receive the frames in array, we'll be converting them to bytes and sending it. And then we have build audio frames. That is where we will be reshaping the audio so that if let's say somebody have a stereo speaker or somebody have a mono speaker, they can simply select one or two for the stereo channel, and one for the mono if somebody have only a single speaker for that. And then we'll be using the S16 format, and the layout will be mono again. And then we have the timestamp. So here we have the PTS. PTS is basically if there are multiple audio frames that are coming in, and let's say some audio chunks are coming before the next one, or if it's let's say asynchronous, if it's not synchronous, then we simply check the timestamp and we again synchronize the audio packets, and then we will be sending it. And here we will be receiving the audio stream from the AI itself. The method is from the video SDK, where we get the streams, and then it will be initialized when the call gets started, and to calculate how long it will take to maintain the correct playback timing, and we'll have to wait to maintain the timing itself. And we have get frame buffer. uh, if let's say somebody goes silent for some time, then we will be sending zero basically, in order to handle that. And then we will be finally we'll be sending all of those frame within the meeting. And yeah, that's all for the agent part. uh, I think the bot was not audible before, so I'll be demonstrating it again. Okay, let me just start it again. Let me demonstrate it again. So I'll enter my name here. I'll invite the agent again. Now I'll share my screen here. Now I'll simply ask the bot. I'll again check if my mic is not mute. Okay, it's not mute. So, hey, what do you see on my screen? I think it's still not audible. How does the UI look like? Okay, let me just share the entire screen here. Yes, can you please give me more details about this page? Can you give me some more details about the page? Thank you for your guidance. So that is it. If you have any questions, please you can ask here. I'll stop presenting my screen now.
Thank you, Harshit, for this awesome live demonstration. Now we would love to hear about the questions all the viewers has. Let us know in the comments. Yeah. If you don't have any questions, then we can stop here. Yeah. Yes.
Ram, yes, you can use 2.0 model as well. You can use any, even if you have any custom model, you can use that as well. There is no restriction to it. We have it open for all LLMs. Thank you, Ram. Thanks for coming to the video.
Is there any other question? Is there anything else you want to ask? Okay. Thank you all for attending this session. There is small announcement for you. We will be conducting these sessions every week, and we would love to hear feedback or any suggestions from you. Thank you for